Hi, I'm Alex McColgan and you're watching Astrum. And today I'm super excited. Why? Because I get to show you the amazing planet that is Saturn. Now as far as planets go, this is my favourite one, which is an Earth. And I think by the end of this video you may agree with me, because thanks to the Cassini probe we have some astonishing imagery of this beautiful planet. I'm going to give you some insights to these pictures, as well as explain everything you could want to know about the sixth planet from the Sun. Now Saturn is big. It's a gas giant with an average radius about 9 times that of Earth, making it the second biggest planet in our solar system. I say average radius though, because its equatorial and polar radii differ by almost 10%. The radius is 60,000 kilometers at the equator versus only 54,000 kilometers from pole to pole. Now Saturn is only 1/8 the average density of Earth, being 0.7 grams per centimeter cubed, compared to Earth's very dense 5.5 grams per centimeter cubed. But because Saturn is so much larger, it has the mass of over 95 Earths. Interestingly, Saturn is the only planet of the solar system that is less dense than water, about 30% less in fact, which means if you were to have a bath big enough, it would float. Saturn is classified as a gas giant because the part of the planet we see is just gas. It doesn't have a surface that we know of, although it may have a solid core. But although Saturn is called a gas giant, it's not entirely made of gas. It's got just too much mass for that, especially when we know that it consists primarily of hydrogen, which becomes liquid under high pressures. Saturn has a very hot interior, reaching 11,700 degrees Celsius at the core, which is twice as hot as the surface of the Sun. And the planet radiates 2.5 times more energy into space than it receives from the Sun. But if we look at Saturn through the infrared, we see Saturn's glow represented in brilliant shades of electric blue, sapphire and mint green. On the night side, with no sunlight, Saturn's own thermal radiation lights things up. This light is generated deep within Saturn and works its way upward, eventually escaping into space. Scientists predict that Saturn's interior is probably made of a core of iron, nickel and rock, surrounded by a deep layer of metallic hydrogen, a middle layer of liquid hydrogen and liquid helium, and an outer gaseous layer. But seeing as we can't even land on the surface of Venus for an extended period of time without being crushed, actually testing this theory for Saturn, where pressures and gravity are huge, is a bit of a ways off. Saturn's atmosphere has a banded pattern similar to Jupiter's, but Saturn's bands are much fainter and much wider near the equator. And the reason why Saturn is yellow? It has ammonia crystals in its upper atmosphere. But while the surface of Saturn may appear calm, the planet is actually very active. The winds on Saturn are the fastest among the solar system's planets, after Neptune. They can be a blistering 1800 kilometers an hour. Visible storms are also known to appear on Saturn, like this one that lasted just under a year in 2011. Every 30 Earth years, the planet produces what is called a great white spot, which is a unique but short-lived phenomenon that occurs every Saturnian year. If this storm that we see here wasn't an early rendition of this great white spot, the next one we expect to see is in 2020. In storms on Saturn, lightning is also produced. Cassini has even detected the sounds of thunder. Now while this may sound weak, the power of lightning on Saturn is about 1,000 times stronger than that on Earth. Still talking about storms, but moving on to the planet's poles, we find that each pole has a giant permanent storm. NASA reported in November 2006 that Cassini had observed a hurricane-like storm located to the South Pole that had a clearly defined eye wall. Eye wall clouds had not previously been seen on any other planet than Earth. The ring is similar to the eye wall of a hurricane, but much larger. The clear air there is warm, like an eye of a hurricane. But on Saturn it's locked to the pole, whereas a hurricane on Earth would drift around. The North Pole is even more unusual. There's a permanent hexagon-shaped storm that rotates with the planet, but it doesn't change longitude like the rest of the clouds on the planet. The straight sides of the polar hexagon are each about 13,800 kilometers long, making them larger than the diameter of Earth. And why does this happen to such a big scale? Well, no one really knows. Nature seems to have a thing for 60-degree angles though. Anyone seen Giant's Causeway? But like the South Pole, the North Pole also has an eye wall vortex in its center. Now, while not anywhere near as strong as Jupiter's, Saturn does have a magnetosphere, which is strong enough to deflect the solar wind from the Sun. And Saturn's magnetosphere, much like Earth's, produces aurora. Their location and brightness strongly depends on the solar wind pressure. The aurora becomes brighter and moves closer to the poles when solar wind pressure increases. The same process produces auroras on both Earth and Saturn. Electrons stream along the magnetic field lines of the planet into the upper atmosphere. There, they collide with atoms and molecules, exciting them to higher energies. The atoms and molecules release this energy by radiating light at different colors and wavelengths. On Earth, this light is mostly from oxygen atoms and nitrogen molecules, but on Saturn, it's from hydrogen. Now, the rings for me are one of the highlights of the planet. Saturn has a prominent ring system that consists of 9 continuous main rings, made mostly of ice particles and smaller amounts of rock debris and dust. While they are mainly named after letters of the alphabet, the naming conventions are still a little confusing, so bear with me here. Now, the first 5 rings from the closest to the planet outward are the D ring, which is very faint, C ring, B ring, which is the brightest and widest of all the rings, the A ring, which is the last of the bright rings, and then the F ring. The D ring starts from 66,000 kilometers from Saturn's center, and the last of the bright rings finish at 140,000 kilometers above Saturn's center. These rings are mostly made up of water ice with traces of rock. If we look in the ultraviolet at a section of the brightest rings, it shows there is more ice towards the outer part of the rings than in the inner part. The red in the image represents sparser ringlets made of dirty and possibly smaller particles than in the icier turquoise ringlets. If we look at a picture representing radio occultation, we can judge the size of the individual particles that make up the rings. Color is used to represent information about ring particle sizes based on the measured effects of the 3 radio signals. Shades of red indicate regions where there's a lack of particles less than 5 centimeters in diameter, so generally quite big particles. Green represents particles of sizes smaller than 5 centimeters, and blue represents particles smaller than 1 centimeter. Overall, it's thought that the particles in the rings aren't bigger than 10 meters, and can be microscopic in size. The main rings are thought to be as little as 10 meters thick to 1 kilometer thick. Particularly in the B rings, we can see that the rings are not perfectly symmetrical. During the planet's equinox, the rings can get a bit wonky. Look at the top of this video, where the B ring meets the A ring. Zooming in on this structure reveals ridges and spokes a couple of kilometers tall, their presence given away by their shadows. Zooming out again, we can see the scale of how many spokes there are during this period. Oscillations happen all the time in the rings though, perhaps due to the presence of a shepherd moon, or even just naturally. The differences in these oscillations, which can be seen all in a day, can be up to 200 kilometers. So I've talked about the D, C, B and A rings and also mentioned the F ring. The F ring can also get a bit wonky, and has a perfect example of what is called a shepherd moon, this one being Prometheus, that leaves a ripple in the ring as it orbits. Once during its 14.7-hour orbit of Saturn, Prometheus, which is only 63 miles or 102 kilometers across, reaches the point in its ecliptical path where it is farthest away from Saturn and closest to the F ring. At this point, Prometheus's gravity is just strong enough to draw a streamer of material out of the core region of the F ring. And that's what causes these ripples which you can see. So what comes after the F ring? Well, the first after the F ring is Janus, or the Epimetheus ring, then the G ring, the Palleni ring, and then the E ring. I know it's a little bit confusing, but bear with me and I'll go through it again. Now look at this picture, it's absolutely amazing, and I might just do a separate video on this, but for the sake of time, this bright blue ring you see on the outside is the E ring. And just below that you can see the faint Pelleni ring at the top of the picture. The G ring is the next distinct ring, and you can just about see the Janus or Epimetheus ring also at the top but just below it. And can you see us? We're also in this picture. There, right in the corner, is Earth and its moon. So now you know a little bit about the rings. I think you'll agree that they are so interesting in their own right. Theories abound as to why they're there, but we simply don't know. We know that some of the moons are responsible for some of the material there, but we also know that some of the material there is responsible for some of the moons. And talking of moons, I'm going to give you a brief rundown about those that belong to Saturn. Again, I do plan to actually do a separate video or even videos about them, as there are at least 150 moons and moonlets. 53 with formal names. They come in all shapes and sizes, and most uniquely, Saturn's biggest moon, Titan, which is even bigger than Mercury, is the only moon in the solar system with a thick atmosphere around it. I'm also going to throw in here that Saturn has the Death Star orbiting it, biding its time. We call it Mimas. Sadly, we're coming to the end, and I've just got one last thing I want to talk about. I want to talk about Saturn's orbit. Saturn orbits about 9 to 10 times further away from the Sun as Earth does. And 1 year on Saturn can take 30 Earth years. But funnily enough, a day on Saturn is different depending on where you're stood. Not that you really could stand on Saturn. At the equator, or at the poles, a day lasts about 10 hours and 14 minutes. Elsewhere, so everywhere apart from the poles and the equator, a day lasts 10 hours and 38 minutes. The issue is, because Saturn isn't solid, it's not bound to rotate at the same speed all over. I just want to leave you with this. Few sights in the solar system are more strikingly beautiful than softly hued Saturn embraced by the shadows of its rings. And look at this beautiful change from gold to blue. It's a striking visual effect that scientists don't fully understand. Current thinking says that they may be related to seasonal influences tied to the cold temperatures in the northern winter hemisphere. And despite all that we have learned from the probe Cassini, Saturn remains a world of mystery. I really appreciate you watching this far, and if you did find this video interesting, then I'd ask you to please like and share it, as it helps me out a lot. I'm still a small channel and I'd love to be able to grow. I plan to do a video for every planet in our solar system. I've already made a video for Mars and Mercury, and if you enjoyed this video, I'm sure you'd like those ones too, so you should definitely check those out. I will of course continue to keep making videos about our solar system and beyond, so really, please subscribe and you won't miss any of the future things I've got to show you.